Hello and welcome to This Week in Science, the show where I highlight some interesting science stories I've noticed recently. In the last episode, which was about 3 months ago, so you'll be forgiven if you missed it, we looked at two prehistoric birds, the Ichthyornis and the Archaeopteryx. You can click on the card above to watch that episode. This week we have a very fishy theme. Our first story this week concerns a 67 million year old shark. The newly discovered species of shark has been named Galagodon, after the 1981 Japanese-US game Galaga, because its teeth resemble the player-controlled spaceships in the game. One fascinating thing about this discovery is the location the fossils were found in. The teeth were found in the sediment left behind from the excavation of another famous fossil, that of Sue, one of the largest T-Rex specimens ever discovered, although I believe since I wrote the script another one has been discovered which is just that little bit bigger. Galagodon would have swam in the river systems of what is now Dakota. 67 million years ago, what is now South Dakota would have been covered in forests, swamps and winding rivers. The shark may have lived at the same time and place as T-Rex, but don't go thinking the shark would have taken a bite out of a paddling dinosaur. The teeth measure only 1 millimeter each, and the entire shark, which is related to modern carpet sharks, would have grown to around 12 to 18 inches long. They were likely to have fed on small fish, snails and crayfish. Two researchers sifted through 2 tons of dirt to find 24 tiny teeth. Terry Gates, one of the researchers, said, "It amazes me that we can find microscopic shark teeth sitting right beside the bones of one of the largest predators of all time. These teeth are the size of a grain of sand. Without a microscope, you just throw them away." Well, moving on to our second story this week, and sticking with the prehistoric fishy theme, we have a discovery that looks to change our understanding of the evolutionary history of hagfish. The hagfish is sometimes known as a slime eel due to its ability to produce vast amounts of mucus as a defense mechanism. Just take a look at this picture when a truck carrying a cargo of hagfish crashed. Hagfish don't have eyes or jaws or teeth to bite with, but instead they use a spiky tongue-like apparatus to rasp flesh off dead fish and whales at the bottom of the ocean. There has been disagreement among scientists about the evolutionary history of the hagfish for many years. Scientists who only look at the fossil record tend to conclude that hagfish are so primitive they are not even vertebrates. This implies that all fishes and their vertebrate descendants had a common ancestor that more or less looked like a hagfish. But those who work with the genetic data argue that the lampreys and the hagfish are more closely related to each other. This suggests that modern hagfish and lampreys are the odd ones out in the family tree of vertebrates. In this case, the primitive appearance of hagfish and lampreys is deceptive, and the common ancestor of all vertebrates was probably something more conventionally fish-like. By the way, if you're interested in the lampreys, I have a video all about them, and you can click on the card above to see it. But recently, scientists from the University of Chicago discovered a fossil hagfish that filled a 100 million year gap in the fossil record and looks set to settle the debate. The fossil, named Tethymyxine teparostrum, is a 12-inch long fish and was found in the Cretaceous limestone in Lebanon. Imaging technology was used to identify the chemical traces of soft tissue that were left behind in the limestone when the hagfish fossilized. These soft tissues are rarely preserved, which is why there are so few examples of ancient hagfish relatives to study. The scan spanned over 100 concentrations of keratin along the body of the fossil. This keratin is what makes the slime defense of the hagfish so effective. Hagfish have a series of glands along their bodies that produce tiny packets of tightly coiled keratin fibers, lubricated by mucus. When the keratin fiber hits the seawater, they expand and turn the water into slop that can choke the gills of attacking predators. This fossil shows that the hagfish is more closely related to the blood-sucking lamprey than to other fishes. This means that both hagfish and lampreys evolved their eel-like body shape and strange feeding systems after they branched off from the rest of the vertebrate line of ancestry about 500 million years ago. Well, that's it for this week. I'm now looking directly into your eyes, not at what I was just reading, but thank you for watching this week. Links to the articles covering today's stories will be in the description, and don't forget to click on the card above for links to the last episode in the series, and also my video on the Ichthyornis and the Archaeopteryx if you're interested in prehistoric birds. We'll hope to see you next week. Until then, stay curious, ask questions, and keep learning. Goodbye.